Good morning to all. Myself, Komal, and doing PhD under the supervision of Dr. Vikas Sindhu from MDU Rohtak, and co-supervisor is Dr. Atish Amal Haq from Samia Millia Islamia, New Delhi. Here I am presenting my paper under the title of Challenges and Requirements for Integrating Renewable Energy System with Grid. In this paper, we are discussing about various challenges associated with the grid integration. First one is grid stability. In this paper, we talk about fault ride-through, uh, phenomena of fault ride-through using reactive power injection approach. This reactive power injection limit the value of current overshoot at the time of fault, at the time of transient. In this way, we able to maintain a constant average active power, and this will help in stabilize the system. All these experiments are performed with 16 kilowatt three-phase grid connecting PV system. Actually, renewable energy has two main characteristics. These characteristics which distinguish it from the other conventional energy generation. First one is its variable nature, and second one is a high degree of uncertainty. These two quality affects the operation and the planning of bulky power system. Various problems are also associated with renewable energy system, like water pollution in case of solar PV modules, and harmonic distortion when the power quality is measured. There is a block diagram of three-phase grid connecting photovoltaic system. There is a PV system, and then inverter, and LCL filter, and grid. Uh, for the control mechanism, there is a PLL and controller, and we also use MPPT. Various grid integration stages. For stage one, uh, various well-defined standards and equipments should develop in stage two. Feature planning case model should be prepared by the market operator. At this stage, the stage two, network model is prepared, and all these generation resources, for three studies are included. For all the generation resources, three studies are included. First one is steady state analysis, and second one is short circuit study, and the third one is dynamic and transient stability analysis. In case of steady state analysis, we use N-1 contingency approach, and short circuit study, we use current limiting facility. There are requirements for compliance with grid code. Year to year, there are various codes are given, like in year 2000, in March 99, utility of standard transmission made, and this rule is approved in January 2000, and it will be effective in Feb 2000. After that, in 2002, some standards are we revised the clause 1.5, which is reporting of non-compliance, replacement of full account with UI settlement system. Uh, and this rule is effective from March 2002. In year 2006, we decided that regional load dispatch shall keep account of energy or power flow from the grid. Then grid code should be specified, and the revision is according to CERC standards not by IEGC. After that, some standards are comes into picture in year 2010, and after that 11 and 12. Uh, Penetration of renewable energy is increasing day by day. Strong, strong requirement of strict grid codes arise from the grid operators, transmission system operators, and grid operators are like transmission system operators and distribution system operators. Also, reactive power requirement for wind generators also arises. Similar power specification is demanded in other grid codes for wind generators. According to national electricity rules, wind generation should have some characteristics like at the full operating days, along with the full output at the point of connection, and reactive power control, etc. Analysis for integration challenges. Why the grid code requirements are needed. It is just because for the grid managements and reactive and active power control, and uh, at the time of transient, we find fault right through phenomenon in terms of voltage and frequency. Here are some simulation results which explain the situation. These results are for ideal situation, like without harmonic. These results are in terms of voltage and frequency, like low voltage right through, high voltage right through, and low frequency right through, and high frequency right through in weak grids and without harmonics. Here I am explaining the first phenomena, which is LVRT in weak grid without harmonic. In this situation, we can find out when the line voltage drops, then there should be an increment in line current. These two changes results in direct and quadrature current components. This current component is decreased and increased accordingly at the time of fault, and this results in active and reactive power control. Similarly, we can explain the other three results also. Conclusion. When penetration of renewable energy with grid occur, it creates more uncertainties, and also some technical challenges also arises in the grid operation. In this paper, various challenges with the renewable energy integration with the grid, like various as aspects of renewable energy system with the grid, like grid integration studies, and few analysis like steady state analysis, short circuit analysis, dynamic and transient analysis, various grids, standards and requirements for compliance with grids are discussed. Here are few references we use in this paper. These are the references. Thank you.